All right, we're going to finish up the rest of this first review, and this is what I have for now. So we're on page 3, number 12. It says find the area of the shaded region. The radius of the circle below is 10 centimeters. So I do this proportions way. If you want to do it a different way, you can do it that way. But the proportions are awesome because they work for most of the problems and they make a little bit more sense. So the shaded region is our main focus here, and we first need to find the angle that's going with the shaded region, and that's going to be 240, because 360 minus 120 is 240. So I'm going to do 240 out of 360 equals, I don't know what the area of the shaded region is, but I do know that the area of the whole circle is going to be 100 pi, because the radius is 10, and remember, the area is pi r squared, so I get 100 pi. All right, so now I just have to solve this proportion. I get 100 times 240, which is, I should probably know this, 24, oh, I shouldn't know that, add 3 zeros. 24,000 pi equals 360 times x. So I'm going to divide by 360. And I get the area to be 66.67. And don't forget your pi at the end. Or if you want to get rid of that pi, multiply by 3.14 and you get 209.3. In our units, I believe the radius was in centimeters. So we're going to do centimeters squared. So we have quite a few circles coming up here. So number 13 is the same sort of idea. What I told my students is pretend like this whole thing was shaded. Find that area first. So we're going to do 90 out of 360, which if you can see that's a fourth, you can just divide the area of the circle by a fourth, but I want to stay consistent with what we just did. So 90 out of 360 equals x out of the radius in this case is 8, so the whole circle is going to be 64 pi. Cross multiply. I get 64 times 90 divided by 360. This is going to be 16 pi. So that means if this whole thing were shaded, that's the area of the sector. The whole sector. Right? But what we're really looking at is the sector, and we're taking away a triangle. So my next task is to find the area of the triangle. It's going to be 1/2, and since this is a radius, this is also a radius, so I get 8 times 8. And so my area of the triangle is 32. So I pretended first that this whole thing was shaded. That was 16 pi. And now I'm taking that chunk of the triangle away, so I have to subtract it. So if you're going to leave your answer in terms of pi, it's 16 pi minus 32 centimeters squared, or if you want to round it to a decimal, 16 times pi minus 32 gives me 18.27. All right. Number 14 is a question you should go, oh, I like this one because it's pretty straightforward. The only thing you need to remember is this terminology right here, which is an annulus. And I think of an annulus, it's like a tire. Okay, it's got a little circle with or a big circle with a little one cut out of it. So we know that the radius of the little guy is 5. The radius of the big guy is 7. And green is not a good color to use on a green. Neither is red. So I have 7 and the little guy is 5. So the area of the big circle is 49 pi. The area of the little is 25 pi. I'm going to subtract them, and I'm left over with 24 pi centimeters squared. And the reason I subtract them is the big circle is this whole thing if it were shaded. But I'm cutting out that little circle out of it, so I have to subtract that little circle, just like I subtract the triangle, the triangle from the one above it. And our last circle problem, I think, looks like this. In this one, you have to read the directions very carefully. It says find the value of x if the area of the sector is 50. Well, x is really means find the radius. So your initial thought is probably okay, I know 122 out of 360. That's my first step. But what do I set it equal to? And I always think, well, 122 is the part of the circle I want, and 360 is the whole thing. So I know that the area of the sector, which is my shaded region, is 50, according to my directions here, or my problem. That's part of the circle. I need to know how much the big circle is. And so your inclination is to put x here. However, this is an area of part of the circle. I need to compare it to the area of the whole circle, which is going to be pi r squared. The real thing I'm solving for is this radius squared. So when I go to do this, I cross multiply, I get 122 pi r squared equals 360 times 50, which I believe is 18,000. Let me just verify that. Okay, and so to start solving for r, I'm going to divide by 122 pi. I get r squared equals, I believe it's 46 point something. Now be careful when you do this. If you're going to divide this all at one step, you need parentheses in your calculator. If not, you can do 18,000 divided by 122 and then divide it by pi after that. I get 46.96. And our final step is to solve for r, which is going to end up being 6.85, and what are we working here? Centimeters. And that's just a radius, so it's not going to be centimeters squared, it's just going to be centimeters. All right, we're in the home stretch. Write the proportion to shaded to unshaded area, or of shaded to unshaded area of this pentagon. So that's the key thing, shaded to unshaded. And what most of my students did that I noticed is they started drawing in, okay, I get 5 big triangles in here, but I really only have half of that, so I'm going to divide all those big triangles into half. So in total, I have 10 triangles. However, it says shaded to unshaded. I have 1 shaded, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 unshaded. So my ratio is going to be 1 to 9. If they asked you for the shaded to the whole, that's when it would be 1/10. But it's asking you shaded to unshaded. All right, and we're in the home stretch. 3 questions left, and I'm really not going to do the last one because you know my skills on the measuring tools with the smartboard aren't very great. So the ratio of areas of 2 hexagons is 36 to 49. Find the apothem of the small one if I know the apothem of the large one is 20. So the key thing first is I know the ratio of the areas is 36 to 49. And I'm going to write it as a fraction instead of the colon in between. Now, I need to get the ratio of the sides because an apothem is a one-dimensional object. It's not necessarily a side length, but it's one-dimensional, which makes it part of the sides. Now remember, to do that, all I need to do is square it. Because normally I go from sides to area by squaring. Think of it like area is centimeters squared, and I need to get down to centimeters. So the ratio of my sides is 6 to 7. So I'm going to use that ratio now to set up my proportion. My proportion is going to start with 6 over 7. And I know that the larger apothem is 20. Well, notice 7 is the larger number, so that means my larger number is going to go on the bottom. And I'm trying to find the apothem for the smaller one. So I set up my proportion as 6 over 7, which is the ratio of the sides. 20 is my actual value for the sides. I'm trying to find the actual value for the other apothem, the small one. So my cross multiply, I get 7x equals 120. Divide by 7. X is going to equal 17.14 inches. Now always check, okay, did it ask me to find the smaller apothem or the bigger one? It asked me to find the smaller one. So that's smaller than 20, so it makes logical sense that that's my answer. All right, and the very last one. The ratio of heights in triangles is 2 to 7. So again, heights is one-dimensional, so that's really the ratio of my sides. I'm going to write it as a fraction. It says find the area of the larger triangle if the smaller one has an area of 17. Well, when it's asking me to find an area, I can't use the ratio of the sides. So my area ratio is going to be 4 over 7. No, not 4 over 7. It's going to be 4 over 49. To get there, I just square the top and the bottom. I am now going to use that ratio to find my area. So 4 over 49 equals, find the area of the larger triangle if the smaller triangle is 17. So 4 is smaller, so I'm going to put the smaller one on top. Over x, cross multiply, I get 4x equals 833. I'm going to divide by 4. The area of the bigger one is 208.25 centimeters squared. All right, and again, I am not going to even attempt this last one because my measuring skills on here won't be accurate anyway because your ruler is actually... What I saw, a lot of people either split this up into 2 triangles like this. Whoopsie, that is clearly not a height. And then take their ruler and draw in what looks to be perpendicular. Now you should be using a ruler, I'm just freehanding. And draw in another one going this way to find your height. And then once you measure that, you can just add up the areas and you should get around 51.5. All right, well, hopefully this helps. I will hopefully get the other video done by tomorrow, but this should be a good start. Don't forget your test is coming up Friday and you can come and ask questions anytime.